Bio 1 students, I thought now that we've turned in several lab assignments, it was time to review some of them to make sure you have feedback. Now, I want you to remember that when you do your assignments, we leave feedback on them. So you have personal feedback, but you have to go to your grade book and click to find that feedback. So make sure you do that, okay? But this is going to be more general feedback to help you do a better job in the future. One thing to remember, those videos on how to make error bars, how to write a caption, those are up all year long. You can always go back to those on the lab website to see them. And I highly recommend some of you do, because some of you have forgotten or didn't pay attention to the first time around. So please check those out. Now, one of the first figures we did was a cholera figure. Here's an example of the cholera figure. We have time in days on the x-axis. That's our independent variable. We have the number of new cholera cases per 1,000 people on the y-axis. And then we have the data plotted. So remember, these are averages. And we have standard error bars on there. One way I can quickly tell if you didn't do this correctly is if these error bars are all the same length, because that tends to indicate that they're not done correctly. So please check that when you make a graph to ensure that the error bars don't come out the same length. If so, you probably didn't do custom error bars like I showed you in the videos in the past. Okay, so beneath that then we have the caption. This is where students struggle the most. So we always start with the word figure and a number, typically figure 1, unless there's more than one figure in an assignment. Then you might have figure 2 and 3. So figure 1, period. Then a title, the number of new cholera cases per day in Zimbabwe, period. Then you describe the data quantitatively. From day 1 to day 10, or from the first day till day 10, there was a 530% increase in cholera cases. Or you could do fold change. Remember, in your lab manual, there's a page that shows you, it's in the appendix. It shows you how to make a figure in terms of what it should look like and what a caption looks like. And it shows you how to calculate percent change, and it shows you how to calculate fold change. You can use either one of those. So from day 10 to day 35, from day, let's start over. From the first day to day 10, there's a 530% increase in cholera cases. From day 10 to day 35, the data plateaus. That's when it levels off. And then before the period, I have in parentheses mean plus and minus SE, n equals 3 for each data point, period. So I have sample size listed. I let the reader know that these dots are averages and that these are standard error bars. Okay, so there's an example of this assignment properly completed. You can compare that to what you've turned in. Here's an example of a standard curve from the beta cyanin lab. We have absorbance, and you could have units here, AU, absorbance units. I did not grade off for that because I didn't really push that very hard myself. But absorbance, you could have AU in parentheses. Beta cyanin concentration. Now this graph right here should have a concentration, a unit listed. It does not. So that should be micromolar, right? So there's something missing on this example figure. Here are the different absorbances of the different concentrations. And then we have a figure caption. Once again, figure 1, a title, we quantify the change. So if I were doing this caption, I would quantify the change from here to here because it's linear. There's no sense in quantifying all of these changes. Although you could quantify from 0 to here because this one kind of jumps out of place a little bit if you wanted to, and then describe the change from here to here. But you want to quantify that change. Give it a percent change. And then make sure you end the caption with a mean plus and minus SE for each trial and however many samples there were. So what was the sample size? If you don't know how to do sample size, remember it's the number you divide by to get averages for your data points. All right, then on that same assignment, there were some questions. What is the slope of the best fit line? In this case, it was 0.064, and really you should have units on that as well, like 0.064 absorbance units per micromoles or whatever, right? You should have some kind of unit on that. But I accepted just the numbers on this assignment. Number 3, if the absorbance of beta cyanin was 0.3, what is the concentration of the solution? You have to solve that using your best fit line, the equation of the line that you can insert on Excel. And then if you do that, you'll get roughly about, at least for my sections, about 5 micromolar for that answer. So I accepted anything from like 3 to 8 micromoles as a potential answer there for depending on your class section's data. Number 4, if a 2 molar beta-cyanine solution was 525 nanometers, if that's the absorbance, if that's what lambda max was, what would lambda max be for a 4 micromolar solution? It would still be 525 nanometers. Lambda max does not change. Those peaks stay the same. They go up and down depending on concentration, but they don't shift left to right. If you were in lab and you did it, you probably know that if you paid attention. Lambda max does not shift. Absorbance changes. Lambda max does not. Lambda max is which wavelength is most absorbed. In the case of beta-cyanine, it was green, right around 525 to 535 nanometers. The most recent assignment then was to use that standard curve to convert some data from a lab that we didn't get to do in person, where we put beets in ethanol concentrations and see how much ethanol damages cell membranes. And how do we measure cell membrane damage? By measuring how much beta-cyanine leaks out. Okay, so here we have a figure. We have beta-cyanine in micromolar on this axis, and down here we have ethanol in percent on the x-axis. Here's what the data pretty much looks like, and you needed to have converted this data to concentration. If this is still in absorbance, then it's wrong. The graph will look about the same shape, but it needs to be in micromolar concentration. And then we have a caption. Figure 1, the effect of ethanol on beet cell membrane damage. Period. Next statement, from 0 to 20% ethanol, there is no change in cell membrane damage. How do I know that? Look, here's 1, 2, 3, 4 data points, and they all have about the same average, and their error bars all overlap with the averages here. That means they're likely not significantly different. Okay, so I wouldn't call that a plateau. A plateau is when you go up and then level off. But when you start off flat, it just means there's no change. Okay? There is no change. But then from 20% to 50% ethanol concentration, there is a 210% increase in cell membrane damage as measured by beta-cyanine leakage. A lot of errors I'm seeing when you're writing these things is you're leaving out details. You'll just say from 20 to 50 there was a 210% increase. Okay, from 20 to 50 what? From 20 to 50% ethanol, there was a 210% increase in cell membrane damage as measured by beta-cyanine leakage. You need to put that verbiage in there so I know what you're talking about, or your TA knows what you're talking about. Last statement in this case, mean plus or minus SE, once again, n equals 6 for each data point. Okay, so those are some of the major assignments we've had this semester, and these have been examples of kind of what we're looking for. I hope it's helpful, and it'll help you improve your assignment as you now work on graphing your osmosis data. Before I close out, I want to show you an example of the interpretation from the cell membrane damage lab. This is what we're kind of looking for. Interpretation is not just telling me what happened again, it's why it happened. Okay, so here's an example. Low levels of ethanol do not cause cell membrane damage. Figure 1. I tell them, see it on the figure. Figure 1. This is likely because beets can make their own ethanol in anaerobic conditions and therefore have evolved resistance to low levels of ethanol. Carafit et al. 2020. That's the lab manual. That's information's right there. If you read it, you've got that information. You should have read it. You're in class, right? At high levels of ethanol concentration, beta-cyanine leakage increases. Figure 1. That tells the reader, go back to figure 1. This is the way you want to write when you're writing your lab report, okay? This indicates that ethanol, an amphipathic molecule, is either dissolving the phospholipid bilayer of the plasma and tonoplast membrane or denaturing proteins in those membranes. This causes beta-cyanine, I have a typo there, but beta-cyanine leakage to increase between 20 and 50% ethanol. I could say figure 1 again right there to refer to it. So what have I done here? I have described what happened and I have described why it happened. And that's what we're looking for on lab reports and anytime you need to interpret data.